Hello, we will continue solving some problems based on electromagnetic induction. Now you can take this. A metallic rod of length L is rotated with angular frequency. L is rotated with angular frequency omega. Angular frequency omega with one end hinged omega with one end hinged at the center and the other end at the circumference of a circular metallic and the other end at the circumference of a circular metallic ring of radius L. Comma, about an axis passing through the center and perpendicular to the plane of the ring. A constant and uniform magnetic field B, B parallel to the axis is present everywhere. Deduce the expression for the EMF between the center and the metallic ring. Deduce the expression for the EMF between the center and the metallic ring. Let me read once. A metallic rod of, it should be of, F, okay. So a metallic rod of length L is rotated with angular frequency omega with one end hinged at the center and the other end at the circumference of a circular metallic ring of radius L, comma, about an axis passing through the center and perpendicular to the plane of the ring. A constant and uniform magnetic field B parallel to the axis is present everywhere. Deduce the expression for the EMF between the center and the metallic rod. So first let us try to find out what are the given quantities. We have a metallic rod of length L. Now let's say this can be our rod of length L. Now this rod is rotated with an angular frequency omega with one end hinged at the center and the other end at the circumference of a circular metallic ring of radius L. Now we have a circular metallic ring whose radius is L. whose radius is L. Now this metallic rod is rotated in this. So this is the metallic rod you can take. The metallic rod is hinged at the center and then it is rotated. It is given. So it's one end is hinged at the center and the other end of the circumference of a circular metallic ring. So the other end is at the circumference of a circular metallic ring, and it is rotated about an axis which is passing through the center and perpendicular to the plane of the ring. So this is axis will be perpendicular to the plane of the ring. Now this rod is rotated with angular frequency omega. So given length of the rod, L, also radius of the ring, that's also equal to L. Then what else is given? The angular frequency omega with which this rod is rotated. Angular frequency is omega. Now when this is rotated, the flux linking the coil changes because we have a uniform magnetic field be present parallel to the axis. That means it is parallel to the axis. The axis is nothing but I can take it as an area vector which is passing through the center. Because B is parallel to A, B and A are parallel to each other here, because it is given that B is parallel to axis. What is the axis? Axis is perpendicular to the plane of the ring. Therefore B and A are parallel to each other. The angle between B and A is 0. That means there is a maximum flux here. Now reduce the expression for the EMF between the center of the metallic ring. The EMF is induced due to change in flux when the rod is rotated. Now to calculate the induced EMF, first of all we need to find out what is d phi by dt, because we know the induced EMF is given by, we know the induced EMF, E is equal to d phi by dt. So let us find out what is d phi by dt. Now phi, we know the equation BA cos theta. Here theta is 0, so phi is BA, and the magnetic flux is constant because it is B is constant because it is a uniform magnetic field. So here the change in flux is due to change in area because of revolution of the rod. You can write change in flux is due to change in area because of revolution of the rod. Change in flux is due to change in area because of revolution of the rod. Therefore d5 is B into dA. Now what is A? Or we can write before this, first we'll write down what is A. Now therefore change in flux in one revolution d5 is B into area, which is the area during in one revolution is nothing but the area of a circular ring, that is pi r square. R is L, so it is pi L square. d5 is B into pi L square. Now what is dt we will find out. Now time period given omega is the angular velocity, given angular velocity is omega, and omega is 2 pi by t. See, we are taking for one complete revolution, where t is, we will write where t is the time period. Time period. So t can be written as 2 pi by omega. Now E is d phi by dt. The d phi by dt we are calculating for one revolution. So the change in flux in one revolution is B into area, that is pi into L square, divided by the time dt, time period for one revolution, t, which is equal to B into pi L square divided by t is 2 pi by omega. Or simplify this, you will get it E as the induced EMF. A is pi will get cancelled. Therefore E is B omega L square divided by 2, or half B omega L square, and this is the required expression. E is half B omega L square. I will just repeat the steps. To know the induced EMF or to calculate induced EMF, you should know what is the rate of change of flux. And in this particular case, because the rod is rotated with an angular frequency omega along the circular path, the change in flux is due to change in area. Now we are calculating this change in flux for one complete revolution. So that is d phi by dt. So d phi by dt you can calculate for one complete revolution. d phi is B into A. Area for one complete rotation is nothing but area of the circular coil, that is pi L square, and t is the time period for one revolution. Therefore you can calculate t from the given omega. You will get t as 2 pi by omega. Substitute all these quantities d phi by dt, you will get the equation for induced EMF as half B omega L square.